All right, so we are starting with our last section, modeling with polynomial functions. So 4 points not on a line or parabola determine the graph of a cubic function. Example 1, write the cubic function whose graph is shown. So again, we've done stuff like this before, ladies and gentlemen. So remember, it's the intercept form. We've done it with the parabola when we had 2 points and a point not on the x-axis. So remember, we can write this as f of x is equal to a, and then remember, we are taking the opposite of those because we're writing it as in intercept form. So that'll be a times x plus 3, and then x minus 1 and x minus 2. Then we are taking that, and remember, now we're taking the point that's not on the line. It's not always going to be a y-intercept. In this case, it was. So again, that tells us our x is 0 and our y is 3. So said our x is 3 and our y's are 0. So 0 plus 3, 0 minus 1, and 0 minus 2. If we work that out, we'll get a, and then we'll have 3, we'll have negative 1, and we'll have negative 2. So 3 times negative 1 times negative 2 is 6, so we'll get 3 is equal to 6a. If we solve for a, we'll get a is equal to 3 divided by 6. If we reduce that, we'll make it 1/2. So our function here is f of x is equal to 1/2 x plus 1, x plus 3, excuse me, x minus 1, and x minus 2. All right. Now, be careful when you put it in because, again, I don't know how it's going to look when we do it on Big Ideas on the website. But I know if it was 2/3 and you put in 0.66, it would mark it wrong. It might mark it wrong for 0.67. They might want the fraction, but we'll find out here. All right, the next one is, remember, in many real-life situations, you cannot find models to fit data exactly. Despite this limitation, you can still use technology to approximate the data with the polynomial model. So example 3, the table shows a person's billable hourly fee, y in dollars in the year t, where t equals 1 corresponds to 2005. Find the polynomial model for the data, then use the model to estimate the fee in 2012. So again, we're going to go to our Desmos calculator. I already put in the the points. Remember, you go to the plus, that'll give you your table. That's what I did. Then we're going to do our plus, and we're going to do an expression here for number 2, which I already had. So remember, we're going to go to, and I have to move this up so I can see my screen. It'd be nice if I could move that. I guess I have to click on it. And here we have it. And I'm going to go and plug in our stuff. So remember, we're going to put y. And then remember, you have to go to the y sub 1. So you're going to go here. I better hide that. And you go to this a sub b. And we're going to make it 1. Not 11. And then remember, you're going to do the tilde. So if we're going to still use this one here, we're going to do the tilde right there. And then I'm going to tell you on this one right here, you can't see it, but if we went and zoomed out, you can kind of see it. Now it doesn't look quadratic, you can tell that. And it's going to be a cubic. So I'm just going to tell you right now, and I'll tell you on the homework which ones are going to be what. So we're going to say then it's A, and then we're going to go to X, and then we're going to say A to the B, which is going to be, actually I need to go back and put it as a sub 1 there too. And then we're going to go back and cube it. So now I'm going to go here and say cubed, and then I'll tab. So you can already see we have a kind of cube, and you'll see it'll start matching up with the data here pretty well. Remember, our R has to be around 0.99. So we're good so far. Well, we're not good, but you'll see we'll get closer to it as we keep going. So then we're going to say B, X, and then on this one we can say squared. Oh wait, I got to go back and see. I always forget that one. With the calculator share, I never had to do that. That's why I keep forgetting that. And then we're going to square that. And then we're going to add C, and we're going to say X. Notice this time I'm not forgetting. And then we're going to put the 1. And then we'll tab, and then we'll do plus. And we'll call it D. All right, so now notice how it does fit the data pretty well there. Again, the closest it is to 1, the closer it is. So it's 0.9997, or 99% of the data is going to be on that graph. So again, kind of look at what we have there, and you might want to write it down. All right, so now we're going to go back. We're going to go to our, we'll go back here, and I'm going to write it down now. What your textbook likes to do here, ladies and gentlemen, is they like to put it, if you have a cubed, they like to go 3 after the decimal point. So again, if you wrote that down, you should get 1.472 t cubed. Now remember, we used x instead of t here, okay? Minus, again, since it's squared, I'm going to go 2 decimal places. And then we had plus 25.4, and I used just 1 because it was 1 decimal place. So again, I'm kind of going with the 3 after the decimal place, 2 after the decimal place, 1 after the decimal, and then the last one, I'm going to make a whole number. Well, it was a whole number on this one anyways. All right. So then it says it wanted us to find, there's our model, and then it says they want us to find the, estimate the fee in 2012. So in 2005, t was equal to 1. So in 2012, okay, if I'm going to add 7 here to get to 2012, I'm going to have to add 7 there. So t is going to equal 8. All right? Don't say it's 7, say it's 8, because I just showed you why. So we're going to plug that in. Your book suggests you can trace it. I don't know how to trace on Desmos, so I'm going to just plug in my answer. And we're talking about money, so we better put it to the nearest cent. And if we do that, we'll find out that we have $211.14 per hour. All right, hopefully that helps you. Hopefully I can figure out how to get out of this now. All right.